increments into Z, and then I will move up off the part. I will do the same thing. I'm going to go back to my position page. I now want to reference or origin out my y-axis under my relative page. That way it will let me do that. So I'm going to hit Y. The Y is blinking. Origin soft key. I now know that's where my 0 is at. Now I'll do the same thing. I will go over 100 thousandths in the plus direction, because when I use my right hand rule of thumb, I'm moving in the positive direction. When I was in X, I went positive that way. In the Y, I'm going positive that way. So that's why I'm moving in the positive directions. If I was on the top right hand side of the block, I would be moving in the negative directions. So now with my Y known, I'm 100 thousandths over. I will go back to my work offsets. I will mouse down to the Y0 and I will type in Y0 measure. So now my machine knows where the location is in both X and Y. So at this point, I need to set a tool length so I can start telling the machine where my Z work offset is, and I will show you in just a second. We're going to call up in MDI tool number 7. I hit program a couple times to get into my work offset, and to get to my MDI page, I'm sorry. T7 in the block, M6 in the block, insert. Okay, so what I'm going to do is I'm going to just bring this down a little bit so that way I can reach it. I will hit my door open request because it has a door lock on it. Now to take a tool out of the spindle, all I have to do is hold it and push this one time. This spindle will remain unclamped as long as the light for tool unclamped is on. What I need to do is I need to find out what the diameter of this end mill is. So I will bring it over to my micrometers. And I will measure over the OD of this end mill. It is right at 3/4 of an inch, right on the money, okay? So when I go to set this tool on the diameter, I know exactly what value I need to put in there. So I'll put my tool back in there. On this machine specifically, it has a certain way that it has to be orientated when it goes into the spindle. When you put it in there, you will be able to feel it. One way you'll be able to turn it very easily when it's orientated correctly. You should be able to put it up between the prongs, and you won't be able to turn it very well. So to set this tool, I'm going to set it on a 1, 2, 3 block on my table. So in handle, come off our vise a little bit. If you notice, I've gone below my 1, 2, 3 block, okay? I do not want to try and come down on top of my 1, 2, 3 block because I'll risk the chance of breaking my end mill. So I am below my 1, 2, 3 block. I'm going to put pressure against my end mill as I come up. Once I go all the way underneath my end mill, I will remove my 1, 2, 3 block. I will go down 1 click. I will go down 10 thousandths. I will put my increments into thousandths, and then I will start raising up until my 1, 2, 3 block goes underneath my end mill. This is the most accurate way for setting tool lengths. Now that I've set that in here, we're going to go back to our screen. We are going to be looking for the work offsets page, and we're going to be looking on our offsets. So we have our work offsets and we have our tool length offsets. This is tool 7, and the way we can tell if it's tool 7 is we can go into our current position and we can see that tool 7 is in our spindle. So we'll go back to our offsets. We'll look for tool 7. And then I'm going to do the same thing like I did with my X and my Y. I'm going to do Z input C. I'm not doing Z0, but I'm inputting the coordinates from home to the bottom of that to the top of that 1, 2, 3 block. So Z input C. That's telling my machine that from where it was at home to the top of that 1, 2, 3 block, I am 19 inches, 699 thousandths and 4 tenths. So to set my work offset Z, this value right here, normally on certain setups you would set your tool off the top of the part. Well, in this case we're setting all of our tools, doesn't matter if you're setting 1 or 50, we'll set all of our tools to our 1, 2, 3 block. This is what we would call our Z plane. We have to translate our Z plane up to the top of our workpiece because that's where our program is programmed from. So Z0 in our program is the top of the part, but Z0 right now for the bottom of our tool is the 1, 2, 3 block. So I need to know this distance, which is a positive distance up to the top of my part. So how do we do this? Well, we're going to go right back to our position page, and we're going to do Z, our Z is blinking, origin. So now we know that the top of our 1, 2, 3 block, that is 0. So in my handle, I'm going to come up, I'm going to come over to my material, and I'm going to do the paper method where I'll take a piece of paper. And if you'll notice, as I get close, I'm going to go back to the thousandths increments, and I'm going to come down, and I'm just going to slowly move my paper back and forth until I touch the top of my part. Now I cannot move that anymore. So now I have a known distance between the top of my 1, 2, 3 block and the top of my part. Now on our screen, that known distance is 3 inches, 263 thousandths and 0 tenths. This is a positive value, and this is also the value that we will put into our work offsets for the Z coordinates. So I will hit, let me look back at it again, 3 inches, 263, 2 inches, I'm sorry, 3 inches, 263 thousandths. That is our value. So now when my machine reads Z0 is now going to be the top of my part and not the top of my 1, 2, 3 block. If I did not have 3 inches, 263 thousandths in this Z line, when I went to Z0, my end mill would be going to the top of my 1, 2, 3 block, which would be going through my material, through my vise, to the 1, 2, 3 block. That number is very, very important, and then it's important that you get it in there. Okay? So now that my program has been ran, I'm going to move this off my material real quick. At this point, I would take the rest of my tools and I would set them to the top of my 1, 2, 3 blocks. So on this one tool, before we change it, we will go into the tool offsets, and if you notice, we have 2 more lines of code. Well, this is our geometry, and our geometry is going to be this 3/4 that we did earlier. So 0.750 input is what we would be putting in for that value right there. And I would do that for every tool. The next tool I would call up, if it was tool 8, I would set the tool length on it. I would come over here and I'd set the diameter of it. For drills, you do not need to do that. For all end mills, I would highly recommend that you do it. With that being said, we would be able to output our program. So for putting our program back onto the is diameter. And on Haas's, it'll actually show you if it is radial or diameter. So with that being said, we will put our program back onto our USB. So we ran this program, we've made all the parts we need to, we're done. So I will come back to here, edit, program. I'm going to be in this page, not directory, but the program page. I'm going to go operation. I'm going to look for this I/O, which is input output. I'm going to go for F output. So when I hit F output, it wants me to give it the O set, in which case I would do O2102. 2102 O set execute. We'll see if it will overwrite. Do I want to overwrite? I do. Rewrite. I have now outputted. So now my setup is complete. I have powered up the machine. I have homed the machine. I have loaded my program. I have edge trying to find my work zeros. And I have set the tool links. And I've set the diameters of the tool links. And we have successfully outputted our program under our USB. And that's how you do a setup on a Doosan mill.